Hi guys, let's look at the next question. But before we start, let's quickly revise what we've learned new in this year. The three basic identities: sine square a plus cos square a is 1. Next, 1 plus tan square a is equal to sec square a, and 1 plus cot square a is equal to cosec square a. Three most important things about this exercise. Let's solve a question. So question number 37. I realize that the left hand side is more complicated than the right hand side. So let me start working with the left hand side. It says sine A times tan A, and I notice on the left hand side or on the right hand side where I need to reach has only sec A. So let's see what I can do. Let's start with left hand side. So left hand side would be, I will convert everything into sine and cos. So this becomes sine A times sine A upon cos A, because tan A is nothing but sine A upon cos A, and this is 1 minus cos A. So my numerator is sine square A upon cos A, and this is division of fractions, so this becomes 1 upon 1 minus cos A. Done. I can write sine square A as 1 minus cos square A, and the denominator is cos A times 1 minus cos A. The reason for this step is since sine square A is equal to 1 plus cos, not 1 plus, 1 minus, my mistake, 1 minus cos square A. So I think I am getting to where I want. I notice that the numerator is in the form x square minus y square. So this can be written as 1 plus cos A multiplied with 1 minus cos A, and the denominator is cos A times 1 minus cos A. So 1 minus cos A and 1 minus cos A gets cancelled, and I am left with 1 plus cos A divided by cos A. Let me break this up into two elements. This would be 1 upon cos A plus cos A upon cos A. So 1 upon cos A is nothing but sec A, and cos A upon cos A is 1. This is equal to right hand side. This is what they wanted us to do, and we've been able to prove it. Done. Let's look at the next question. The next question that we're doing is question number 39. So here I want you to pay attention. Can I square both the sides? Yeah, because we've been doing this forever, squaring both sides. In this case, can I square both sides? No, I cannot square both sides because this is not given equal. We need to prove it equal. Had this been equal, if A is equal to B, then A square is equal to B square. Here, A is not given equal to B. The left hand side is not given equal to B, which means I cannot square left hand side and right hand side. So what should I do? I still need to remove the square root sign. What should I do? Yes, I will try and rationalize it. So let's work with the left hand side and rationalize. So this would be within square root sign 1 plus sine A upon 1 minus sine A multiplied with 1 plus sine A upon 1 minus sine A. So I have basically rationalized the denominator. Oh, no, not 1 minus, 1 plus. Yeah? So if I have to rationalize and the denominator is x minus y, then I multiply both numerator and denominator with x plus y, which is what I have done here. So let's see if this helps me with something. So my numerator becomes 1 plus sine A whole square, and the denominator is in the form x plus y into x minus y, which means this is 1 minus sine square A within the square root sign. Now this becomes 1 plus sine A whole square, and the denominator becomes 1 minus sine square A, basically becomes cos square A. The reason being, since 1 minus sine square A is equal to cos square A. Good. Now if I remove the square root sign, the two powers will go, which means I would be left with 1 plus sine A upon cos A. Done. So let me just break this up into two terms, which means this can be written as 1 upon cos A plus sin A upon cos A. 1 upon cos A is nothing but sec A, and sin A upon cos A is nothing but tan A, and this is equal to right hand side. This is what we wanted to do, and we've been able to prove it. So good, let's look at the next question. The next question that we do would be question number 41. Let me just open that question. Here it is, question number 41. Again, a similar question. I cannot multiply the left hand side, I cannot square the left hand side and the right hand side. But here I realize that on the right hand side, what I need to get is 1 plus cos A. And in the denominator, I already have 1 plus cos A. Which means if I have to rationalize, this time I won't rationalize the denominator, I'll rationalize the numerator. Why? Because if I multiply both numerator and denominator with 1 plus cos A, my denominator will, after square root sign, change to 1 plus cos A. So let's just write what I just spoke. I will multiply both numerator and denominator with 1 plus cos A. And I've been repeating, you should always look at where you want to reach. Here I notice that on the right hand side I have 1 plus cos A on denominator, and I notice that on the left hand side I also have 1 plus cos A, but within the square root sign. So since I can multiply this, I have rationalized the numerator. So what I get is, in the numerator, x minus y into x plus y, which is nothing but x square minus y square, in this case 1 minus cos square A, and this becomes 1 plus cos A whole square. Now I know that 1 minus cos square A from this relationship is nothing but sine square A, and this remains 1 plus cos A whole square, and everything is in the square root sign. We need to write the reason being, since 1 minus cos square A is equal to sine square A. Done. So if I remove the square root sign, what I will have is sine A upon 1 plus cos A, which is exactly what I wanted to prove. This is equal to my right hand side, so hence proved. Done. Let's look at the next question. The next question that I do is question number 43. Question 43 says 1 minus cos square upon 1 plus sine A is equal to sine A. Okay, so let me see if I can add or subtract the left hand side, and if it helps me get somewhere. So let's look at the left hand side. Let me take the LCM. The LCM will be 1 plus sine A. So this, I will multiply 1 with this. So this will be 1 plus sine A minus cos square A. Okay, I notice that I can write 1 as sine square plus cos square. So let me just replace 1 with sine square A plus cos square A, and the remaining two terms remain the same, plus sine A minus cos square A, and the denominator remains 1 plus sine A. Reason, since 1 is equal to sine square A plus cos square A. Done. I notice that cos square A and negative cos square A gets cancelled. So in the numerator I have sine square A plus sine A upon 1 plus sine A. Is there anything common in the numerator? Yes, I can take sine A common. So sine A, if I take common, what I am left with is 1 plus sine A. This is nothing but sine A plus sine square A, which is what my numerator was. And here I have 1 plus sine A. Again, I notice that there is something common between numerator and denominator. I cancel it, which means left hand side is equal to sine A, which is nothing but my right hand side. So we've been able to reach where we wanted to go. So hence proved. Done. I repeat again and again, you should look at where you want to reach. On the right hand side, I had only sine. So all I did was just added and subtracted, and I ended up where I wanted to be. Next, let's look at the next question. The next question that we do is question number 45. So Question number 45 says sin A plus cos A upon sin A minus cos A plus something something something. So I realize that on the left hand side, obviously the left hand side is more complicated. So let me start working with the left hand side. So I will have to add them. For adding, I'll have to take the LCM, and the LCM will be nothing but the product of these two. So sin A minus cos A multiplied with sin A plus cos A. That's my LCM. And in the numerator, I will multiply sin A plus cos A with sin A plus cos A, which means this becomes sin A plus cos A whole square. And the second term becomes sin A minus cos A whole square. Done. I still am not reaching anywhere closer to my right hand side. Let's see what I can do further from here. So maybe I can try and open this bracket. If I open it, maybe I will get something. So let's open the numerator and see what I get. So a plus b whole square, which means I will have a square and plus cos square a plus 2 times sin A cos A. That's the first bracket opened, and the second bracket opened would be sin square A plus cos square A minus 2 times sin A dot cos A. And the denominator is x minus y into x plus y, which means x squared minus y squared. Will it help me? Let's see. Let's try. So this should give me x square, in this case sin square A minus cos square A. I realize that in the denominator I have a sin square, so it will make sense for me to keep a sin square somewhere. And so I remove this, and this is common. So 2 sin A cos A and minus 2 sin A cos A gets cancelled. So in the numerator now I am left with sin square A plus cos square A, which is 1. And another sin square A plus cos square A, which is another 1. So now I've got my numerator equal to the numerator of right hand side. So this is 1 plus 1 upon sin square A, and I need to, there is no cos square A in the denominator on the right hand side. So let me replace cos square A with 1 minus sin square A. Done. So the reason for this, since sin square A plus cos square A is equal to 1, and the second would be cos square A is equal to 1 minus sin square A. Nothing but the same reason, but written 2 times because I've substituted it separately. So now our numerator now becomes 1 plus 1, which is 2, and the denominator becomes sin square A minus 1 plus sin square A, which is 2 upon 2 sin square A minus 1, which is nothing but the right hand side. So hence proved. Done. That finishes this question for me, and this finishes this video for me as well. Let's look at the homework questions. So the homework questions for you would be question number 37, 39, 41 and 43. Thank you so much. Take care. Be safe. I'll see you with the last video of this exercise. Thank you.